This one is question number 7 from June 24, paper 4-3. The diagram shows a track ABCD which lies in a vertical plane. The section AB is a straight line inclined at an angle of 30 degree to the horizontal and is smooth. The section BC is horizontal straight line and is rough. This BC is rough. The section CD is a straight line inclined at an angle of 30 degree to the horizontal and is also rough. The length of AB, BC, and CD are each 2 meters. A particle is released from rest at A. The coefficient of friction between the particle and both BC and CD is mu. There is no change in the speed of the particle when it passes through either the point B or C. It is given that mu is equal to 0.1. Find the distance traveled by the particle when it moves up the CD and having speed 1 meter. Now the particle moved up the plane CD. We want to find out this distance when the speed of the particle is 1 meter per second. Now we will use energy method to find out the distance x or d. Now the energy method is work done by the driving force plus loss in energy is equal to gain in energy plus work done against resistance. Now there is no driving force, so work done is 0. The loss in energy is in the portion AB, where there is a loss of potential energy, which is mg sine theta into x into distance move, which is 2. mg sine 30 into distance moved is 2. There is no loss of energy in this section AB. Now gain in energy is the potential energy gained by the particle in the section CD. And this one is again mg sine theta into distance moved. mg sine 30 into distance moved is unknown, d, which is the requirement. And there is also an increase in the kinetic energy, that is half m. The speed of the particle is 1. This one is the increase in kinetic energy. When the observation starts from A, the kinetic energy is 0. When the observation ends, the kinetic energy is 1. So there is a gain in kinetic energy. Initial kinetic energy is 0. Now work done against resistance. Now throughout the motion BC, there is a frictional force mu r and the distance moved is 2. So mu r into 2. Again, from C up the plane, there is a resistance, there is a friction, that is mu r And in this case, R is different. Let this one be R1 and this one be R2. And the distance moved is D. Now we will mg, m is unknown. Mg sine 30 into 2 is 1 is equal to mg sine 30 is 1 by 2 into d plus half m plus mu. R1 is the normal reaction when the object is on the section BC. So normal reaction in this case is equal to mg into 2. And normal reaction in the case when the object is on the plane CD is mg cos 30. This one is the weight of the particle mg. This one is mg cos 30. And this one is the normal reaction R2. On this section, this one is mg and this one is R1. So mu into mg cos 30 into d. Now we will cancel out m in all the terms. Now we have g is equal to 5t, g is 10 plus half plus mu is given 0.1 into 10 into 2 plus mu is given, which is 0.1. G is 10. Cos 30 is 0.8666. We will use 4 significant figure within the calculation into t. Now 10 is equal to 5t plus 0.5 plus 2 plus 0.8666 d. Now 7.5, 10 minus 2 minus 0.5 is equal to 5.8666 d. Now d is equal to 7.5 divided by 5.8666. 7.5 divided by 5.8666. This one is 1.29. Meter is the distance moved by the particle when the speed of the particle is 1. B is 1.28. Now, part B. It is given that when for a different value of mu, the particle travels 1 meter up the track from C before it comes to instantaneously at rest. Find the value of mu and the speed of the particle at the instant that it passes C for the second time. Okay, now the distance is given. Distance is given 1 up the plane, and the speed is 0 because the particle is instantaneously at rest. This distance is 1 meter and the speed is 0. Now the particle starts with rest and ends at rest. So there is no change in the kinetic energy of the particle for the whole experiment. Now again we will use the energy method. Work done by the driving force plus loss in energy is equal to gain in energy plus work done against resistance. Work done by the driving force, there is no driving force, 0. Loss in energy is the only energy in the section AB where there is a loss of potential energy, mg sine theta into x. Mg sine 30 into distance moved is 2 is equal to gain in energy. Gain in energy is the only energy, potential energy gained in part in the section 3, that is CD, which is mg sine theta into 1. The distance moved up the plane is 1. Mg sine 30 into 1. Now work done against resistance. There are two work done against resistances. One is in the plane BC and other one is in the plane CD. In the plane BC, the work done against the resistance is mu R1 into distance moved. Mu R1 into distance moved is 2. For the second section, the work done against friction is mu R2 is the friction into distance moved is 1. Now, first of all, with the help of this equation, we will find out mu mg sine 30 into 2, 1, mg into 1 by 2 plus mu. In the section BC, R1 is equal to mg into 2. In the section CD, R2 is equal to mg cos 30 into 1. Now we will cancel out m in all the terms. G is equal to G into 1 over 2 plus 2G mu plus G into cos 30 is 8.666 mu. Now 10 is equal to 5 plus 20 mu plus 8.666 mu. 10 minus 5 over 20 plus 8.666 mu. Mu is equal to 5 over 28.666. The answer is 0.174. This one is the value of mu. Now the particle move will particle is now the particle is instantaneously at rest. Now the particle will move downward and reach at point C. Now we want to find out the velocity of the particle at point C. Now we will again use the energy method to find out the velocity of the particle at point C. There is no work done by the driving force. Loss in energy is the potential energy of the particle, mg sine theta into x. Distance moved along the plane is 1 is equal to gain in kinetic energy is the gain in energy is the kinetic energy, and that is half m into we want to find out the final energy, and the initial kinetic energy is 0 plus work done against resistance. The resistance is mu r in this case, mu r2. R2 is mg cos 30 into distance moved is 1. Now we will cancel out mu in all the cases, in all the terms. G into 1 by 2 is equal to half v square plus mu is 0.174 into 10 into cos 30 is 0.8666. 5 is equal to half v square plus 1.74 the actual value was up to 4 significant was 1.744 into 0.8666. This one is 1.511. 5 minus 1.511 into 2 is equal to v square. 5 minus 1.511 is equal to into 2 is equal to 6.978. The final answer is 2.64. So the velocity of the particle when the particle reaches C is 2.64.